Getting started with KMeans clustering in Python. Welcome! In this lesson, you will discover how to group similar data automatically using KMeans clustering. No experience needed, you will learn step by step. What is clustering? Clustering is a way for computers to sort things into groups based on patterns. Why learn KMeans? KMeans is a popular and simple clustering algorithm. You will use Python and real-world data to make clusters. Let us begin our journey. Running the cell now. We start by telling Python to ignore warnings, so your notebook screen stays clear and less overwhelming. This comment reminds us to hide unnecessary details while we learn. We bring in the warnings module, which deals with messages about tricky code. This command silences those warnings, letting us focus only on what matters. Running the cell now. Staying focused helps beginners learn faster. Ready for the next step? Now we gather the main tools for clustering. This comment is a note for you about what comes next. Pandas helps us work with tables and data rows, like a spreadsheet. This imports KMeans, our main clustering tool from scikit-learn. Matplotlib lets us create charts and visualizations. This tells Jupyter to show charts right in your notebook. Running the cell now. With these imports, we are ready to explore real data and start clustering. Data setup. We will use the mall customers dataset. It contains information about people shopping at a mall. You will see how clustering can help find groups, like similar types of shoppers. Running the cell now. Let us load our data using pandas, and then peek at what is inside. This is a comment showing what we are about to do next. This is where we save the web address of the file. We read the CSV file and load it into a table called df. Here we remove leading white space in the column names. This comment tells us we will list some useful information. We print out how many rows and columns our data has, so we know its size. This shows us the first 5 rows, so we can see what the columns and values look like. Running the cell now. Try counting the columns and guessing what each one means. Always check for missing data, it can cause problems for clustering. This is our reminder that a little checking now can save confusion later. This asks pandas to count any empty spots in every column. Running the cell now. Did you find any columns with missing values? Choosing features for clustering. We do not need every column for clustering. Let us pick 2 columns to group people, annual income, $, and spending score, 1 to 100. These will help us find patterns in how much people earn and spend. Running the cell now. Now we choose 2 columns, 1 for income and 1 for spending score. The comment keeps us on track with our plan. We make a new minitable called features with just these 2 columns. Let us see what the first 5 rows look like. Running the cell now. Why do you think spending score and income might be useful for clustering shoppers? Visualizing the data. It is helpful to see data before clustering. Let us make a plot to spot any groups by eye. Running the cell now. We will plot each customer as a dot to look for natural groups. This comment tells us that what we are doing will help us see patterns. This line sets up the plot size, making it easier to see. This makes the dots, placing income on one axis and spending score on the other. We label the bottom axis so we know what it shows. We label the side axis for clear meaning. A good chart always needs a clear, short title. This shows the plot in our notebook. Running the cell now. What do you notice? Are there any clumps of dots? What is KMeans clustering? KMeans is a way to group data into clusters automatically. You tell KMeans how many clusters to find. The algorithm puts similar points together. Each group is called a cluster. A mean is just the average location in each group. Running the cell now. Let us run KMeans with 3 clusters and see what it comes up with. This comment tells us we are about to separate shoppers into 3 groups. We create a KMeans model and say we want 3 groups or clusters. This tells the model to find patterns in features. We save the cluster number for every shopper, now each is in a group. Printing the first 10 shows us how customers have been assigned to clusters. Running the cell now. Practice, try changing the number of clusters in the next cell. How does it change the results? Now it is your turn. Pick any number of clusters you want and see what happens. This line reminds you that learning is about experimenting. This line asks you for a number using input. For example, enter 5. We create a new KMeans model with your chosen number of clusters. We train the model on our features. We add the new cluster assignments as a column in our data. This shows us the clustering result for the first 5 customers. Running the cell now. Try numbers like 2, 4, or 6 and see if the clusters make sense. If you like this, do not forget to subscribe and try this with your own data next time. Now, let us see your clusters in color. This comment shows we will get a colorful chart of our clusters. We set the size for a clear chart. This line creates a loop for every cluster up to our chosen number. We plot the customers in that cluster as dots. On the bottom axis, we use annual income. On the side, we use spending score again. The label tells us which group is which. Alpha makes the dots a little see-through for overlapping. We add a name for the bottom axis. Here we label the side. The chart title says how many clusters we used. This shows a legend so we know the colors. The plot now appears below. Running the cell now. Do the colored groups make sense with what you expected? KMeans finds centers for each cluster. Let us see where these centers ended up. This comment explains that we want to look at the center of each group. We use the model to get the mean points of each cluster. This prints a label so you can tell what the numbers mean. This gives the coordinates for all cluster centers. Running the cell now. Each row shows where a cluster center is, 1 for income, 1 for spending. Sometimes, using too many clusters can make the results confusing. The comment points out we will use more clusters than make sense. Set cluster count high, it is more than needed. Get a KMeans model for 12 clusters. Fit this model just like before. Set up the plot window. Loop over all 12 clusters. Plot the dots for each group. Group by annual income. Each dot is placed by spending score as well. Label with the cluster number, so we see all groups. Alpha for see-through color. Add names to axes as before. Label the vertical axis. Title shows we picked too many this time. Show all cluster labels in a legend outside the chart for clarity. Show the plot now. Running the cell now. Do too many clusters make the chart messy or unclear for you? The elbow method helps you pick the best cluster number. Let us try it step by step. The comment introduces a simple but powerful trick. We make a blank list to save scores for each cluster count. Try cluster sizes from 1 to 10, 1 by 1. Fit a new model for each number. Train it on the features as usual. Add up the model errors, how far points are from their centers. Set up a smaller plot size for this. Draw a line chart with each cluster count and its error. Label the horizontal axis to show cluster numbers. Vertical axis measures how spread out points are from their center. The title reminds us we are doing the elbow method. Show the line chart below. Running the cell now. Look for an elbow in the plot. That sharp bend is often the best number of clusters. Let us use 5 clusters because it looks like a good number. We will check the average values in each group. We add a comment to remember what comes here. Choose 5 clusters, based on the elbow chart. Fit the KMeans model just like before. We label each shopper in the data by their new group. Let us see what a typical customer looks like in each cluster. This groups by cluster and averages their stats. Running the cell now. Is one cluster spending more than the others? What can you guess about them? You can use your model to predict which group a new person would join. A reminder that you can try clustering on totally new people. We make up a new shopper with high income and medium spending. Ask the model what group this new customer fits best. Print out the result, showing which cluster this person would join. Running the cell now. Try changing the values for new _customer and see if they switch clusters. When you are done, it is a good habit to remove columns you do not need. This comment encourages organized work habits. Drop the cluster info from our table and return to the basic data. See that the cluster column is now gone. Running the cell now. You can always add new clustering labels again later if you wish. Let us see where an extreme value ends up. This checks how clustering reacts to unusual data. This note shows how you can check even ridiculous cases. Make up a wild customer with extremely high income but lowest spending. Predict which group this unusual shopper would get. Print the answer. You might be surprised where extreme values go. Running the cell now. Edge cases sometimes join unexpected groups. Try more odd examples if you are curious. Troubleshooting, common errors. KMeans will not accept missing values. You need only numbers to cluster, text will not work. Always pick a random _state for reproducible results. If you get confused, check these spots first. Running the cell now. If things get messy, you can reload your data and features to start fresh. This tip reminds you it is never too late to reset and try again. This reloads the mall data back into DF. Here we remove leading white space in the column names. We make our features table with the same 2 columns as before. Running the cell now. Restarting from a clean slate often helps learning. Give it a try anytime. Try a new challenge. What happens if you cluster using age and income instead of spending score? This line introduces a bonus for those who want to go deeper. Pick different columns, now age and income. Use for groups to see what you get. Fit the clustering just like before. Get out the cluster number for everyone in the table. Set up our plot window again for this experiment. Loop through the clusters to show each group. Plot each group's shoppers with dots. Put age on the horizontal axis. Income is shown on the side for each shopper. Show which cluster by color and number. Dots are made a little see-through. Label the horizontal axis for age. Label the axis for income. Give the chart a short, clear title. Add a legend to label each group in color. Show it off. Running the cell now. Which influences clustering more, age or income? Try mixing other columns and find out. Recap, what have you learned? What clustering is and how to use KMeans. How to load real-world data and prepare it. How to pick the right features and cluster number. How to plot and understand the groups. Tips to avoid common mistakes. How to try new features for practice. Great job! Practice more to become confident. Running the cell now. Thank you for learning KMeans with me. If you enjoyed this lesson, please like, subscribe, and share. Try clustering on another dataset, and let us know your results in the comments. See you in the next Python adventure. Running the cell now.